Hello everyone. So in previous video, we understood how to avoid blocking calls, why it is important, and what are the different scenarios in which we can block the calls. Now in today's session, we will just revise little bit about caching because caching is the technique we are using in every technology and not only in ASP.NET. We are using these things in Next.js as well as React and front end or any backend technologies. So we are trying to dive deep uh, inside the concept caching. But before that, let's revise what exactly we have learned in a previous section. Now, how to avoid blocking calls, why it is important and all. And one more concept we covered in a previous section is minimize large object allocation, right? So it's take more time for the for the processing and fetching the large object, and how to minimize the thing rather than the you where while you are using input output or you are doing read or write operations, then what you will do, you can go ahead with the stream based classes. Now, how to avoid blocking calls like ASP.NET Core apps should be designed to process many requests simultaneously. So asynchronous APIs allows a small pool of threads to handle the thousands of concurrent requests by not waiting on blocking calls. So basically, when we are in a multi-threaded environment, there are the scenarios where a thread is waiting for the particular execution and all. So ASP.NET provides you asynchronous APIs and which allows a small pool, which creates a small pool of a thread, and because of which a request is not waiting, or it's not on a block. It's not on a block. Okay, they are not in a block state. So rather than waiting on a long running synchronous task to complete the thread can work on another request, we can go ahead with the blocking, avoid blocking call with the help of some these technologies. Okay, common performance problem in a ASP.NET Core app is a blocking calls, and that could be asynchronous, and many asynchronous blocking calls leads to thread pool starvation and degraded response side. So what we have to do, do not block the asynchronous executions by calling task.wait or task.result. Do not acquire locks on a common code path. Okay. So ASP.NET Core apps performs best when the architected to run code in a parallel way. Do not call the task.run immediately and immediately await it. So ASP.NET Core already runs app code on a normal thread pool. And so calling task.run only results in an extra unnecessary thread pool scheduling. Next, do not make the hot code paths asynchronous because it's take time and they are frequently required. Do call data access IO or a long running operations API asynchronously if an asynchronous API is available. Do not use task.run. Okay, we covered this thing. Do make controller or rather pages action asynchronous. The entire call stack is asynchronous in order to benefit from an async await pattern. Then for these things, how to understand these things, where to use what, just use a performance maintenance or performance reader technologies like a kind of a profile roles or any extra softwares which are responsible to check or to understand performance of your application. So let's go ahead with the next concept of today's video, which is the caching. So application in ASP.NET are dynamic. This means that the user requested data is often retrieved from the database and then displayed, or resulting in an increased response time. To overcome this performance overhead, developers employ caching. Now, what exactly the caching? Caching mechanism that stores frequently accessed data in a temporary or particular in memory, so that when the same data is needed another time, it can be directly obtained from the memory instead of a database. So this facilitates high page response time by reducing the time it takes to render the page. So to understand this, we have provided lots of different post blogs and some pages which I prefer or I have suggested. So you can go through it. We will see it after the completion of this topic. Next, caching in ASP.NET. ASP.NET has the following main types of a caching: page caching, fragment caching, and data caching. Okay. Now, page caching, we can cache all the page details and we just frequently require it through the cache. Next, if you want that particular amount, a particular block of code should, or a particular section of your page should be cached, then there is a fragment caching. But mostly we focus on the data caching, because in our every dynamic application, what we do, we fetch the data and we display it. These are, we just enter the data and we put it. So like this, we are mostly dealing with the data. So data caching is a little bit important. Okay. And also known as again, there's a partial caching. This similar to the page caching, except that it provides a mechanism to cache only portion of a page. To do this, what you need to do, we need to encapsulate the section we want to cache in a user control. So let's go ahead. What we can more focus on a data caching, unlike the page and fragment caching, which can be either full page or portion or part of a page can be cached. Data caching stores frequently used data or objects, and it also does it happens by storing the result of SQL request from the database in a cache and directly retrieve the data from cache for subsequent request. Now, cache is stored in the form of key and values. Okay, so to put the value or to use it, what we need to do, we can we can use the cache class, and it can be available system.web.caching namespace. The syntax is as follows: cache, whatever the cache you want to store, mention the key and value. If you want to add the new value in the cache, just maintain or insert it by using the key and value. So insert cache is stored in the form of a key and value. And next, caching is an important technique in ASP.NET, improves performance by storing frequently accessed data in a memory. There are different types of a caching: in memory, distributed, response caching, output caching, cache tag helpers are there. So caching, caching store the frequently used data in memory mostly, and access without having the regeneration or refetch of the data. So this improves the performance of a web application or any kind of application by reducing the need to access the database or other slow resources for every request. So ASP.NET provides different caching strategies to optimize the performance based on a type of a data and the pattern you are using. So if your data is stored and or having a single server and single communication channel is there, then you can go ahead with the in memory. Then there are the multiple, your data is distributed throughout the different servers, go ahead with the distributed caching. If you want quick access of a static web pages, then you can go ahead with the response caching. Output caching is available in a kind of a caching available in a ASP.NET MVC, and cache tag helpers available in a ASP.NET Core. Let's understand these things one by one with the example. So in-memory caching will stores the data and data within the application's memory, and which is ideal for single server application where the data can be shared across the multiple requests efficiently. Now, ASP.NET Core example is available. You have to just configure the caching service to your application in a startup.cs or program.cs. In your controller or a service, you can use iMemory cache to store the and retrieve the cache data. So there is a configuration service where we are adding the add memory cache, and wherever we want, it's inside a controller we are accessing. inside the controller, we are just accessing this methods of caching by using iMemory cache. Now, what are the key features of this kind of a caching technique? First, fast, and since it's stored in a memory, so it will be little bit fast, simple to implement, and best for the small amount of a data. Now, limitation, cache will be lost when you refresh or restart your application, and not suitable for the distributed environment. If you have a multiple servers, this particular technique of a caching is not useful. Next one is the distributed caching, is used when you need to share the cache data across multiple instances of your application. And this is helpful in a scenarios where application is running in a cloud or a multiple server. So for the load balancing architecture. Now, ASP.NET Core supports different kinds of APIs or techniques for it, like Redis and SQL servers. We are going to understand Redis in detail in the next course. We are launching the course for the Redis in the next few weeks. And for the distributed cache, it will get used. So it will be little faster. And it will be useful when your system is shared and multi-program, multi-process, multi applications are there. Okay, multiple services, servers are there. In that case, you can go ahead. Key features: data is shared across the multiple application instance and persistent and not tied to the application's life cycle. What are the limitations? Obviously, higher latency compared to the in-memory. It will be little bit slower. Obviously, it's located at particular architecture, so it takes some time. Not that much, little slower than the in-memory caching. Since it involves external services like Redis and configuration complexity, obviously, if you are adding something else external APIs to your application, so you have to configure those things. I don't consider these limitations as limitations, but yeah, these are the things. Now next, response caching. Response caching allows caching the entire HTTP response. This is useful when you want to cache the static pages. Okay, so the page where dynamic data is not available and data is static, and where we are not frequently fetching the live data or dynamic data, then you can store that HTTP response in a response caching. It improves the performance by skipping the execution of a controller logic and service cache responses. In your controller, you can add the response cache attribute, and you can specify some attributes for response cache. What will be the duration, location, cache? Key features are like sorry, it caches HTTP responses, which can reduce server processing time. And you can cache on the client side, server side, or a proxy. So only effective for static and infrequent caching data. So as you can see, there is a action result index, and above it, we are just mentioning the attributes for the response cache. Output caching stores the result of a controller action, and it serves it for the subsequent request. This can be dramatically improves the performance for the pages where content doesn't change frequently in a controller action. So you can use the output cache attribute. So this is the scenario where we can cache the entire HTML output, and we don't frequently fetch the dynamic data. So cache entire HTML output and configurable by query parameters, headers, and etc. Now, only available in ASP.NET MVC, not in a core. So again, you have to mention output cache, duration, and vary by parameters. Now, cache tag helpers. In ASP.NET Core, there are the tag helpers, which allows the partial page or a content of the page can be cached in a Razor views. And this is useful for the components like menus and widgets, where we are storing some fixed data, right? So consider you are adding the address, and there are the states and countries and all these things are. So menus and widgets that are computationally expensive, but those things are drop downs are not frequently change, right? So in that cases, you can go ahead with the tag helper, cache tag helper, sorry. And key features helps cache parts of a page for more granular control and can be set to vary by route, parameter, or other factors. So there's a cache tag, and there are some attributes vary by route and expirations, when it will be expired, and all these things. Now, when you create a cache, there should be an expiration policies. Okay, caching is typically controlled by expiration policies to ensure that the stale data is not served indefinitely. Okay, so your data will refresh. Consider you want the live data, and you want the live data after 5 seconds, 10 seconds. So at that time, that previous cache should be expired and it should refresh or come up with the new data. So it should not mention the stale data. It should not serve you the stale data. So there are two types of expirations, absolute and sliding expiration, and cache dependencies are there. So where absolute expiration, you just mention the fixed amount of time when the cache should be expired. Sliding expiration, the cache entries resets its expiration time whenever it accessed. Next, cache dependency. You can invalidate cache entries based on a specific dependencies like database change or file modification. Consider you want fresh data, but when you want the fresh data, when something inserted to the database, then refresh the cache, or it means cache updation or expiration depends on a particular event. Now, caching in ASP.NET is a powerful way of optimization or optimize the application and its performance by reducing the database calls, right? Or expensive computations. Now, depending on your application's architecture and requirements, you can choose between in-memory caching or for the single server environments, distributed caching for cloud or multi-server scenarios, response caching for HTTP level optimization when you are reloading the same page. So static pages there. So you can go ahead with, or partial page via tag helpers. So proper caching techniques or expirations and validation strategies are critical to ensure that the cache data remains relevant and up to date. So cache expiration policies as well as its types, you can decide as per the requirements. Now, what are the advantages? It improves the performance, better scalability, lower the latency. Now, improve user experience, reduce network traffic, customizable expiration policies, reduce server load, flexible with distributed caching, minimize dependency on external services, granular control over the data caching, and easy implementation. We have a lots of advantages of a caching as well as we have a disadvantages or scenarios where we should not use the cachings. So caching is a powerful technique, but there are scalability for the scalability of applications by storing frequently accessed in memory data in a memory. And however, there are some scenarios where caching may not be appropriate or beneficial or should be avoided. Now, highly dynamic data. We want the data which should be updated continuously, and some read and writes are happening and we want the fresh data every time. So if data changes frequently and unpredictably, caching may not useful. Okay, we can't use it. An example is real-time stock prices or live sports scores where data changes in every second. So there is no use or there is no advantage to store or that data in a cache. Don't go for it. Now, sensitive data, if you have a heavy risk data or sensitive data like banking data or personal use or payment details, don't go ahead with the caching because security will be required for such kinds of a data, right? Limited memory resources. If you have a limited memory resources, don't waste the memory in a caching. Like applications running on a devices with limited memory, such as IoT devices or low-end mobile devices. Fourth one is like one-time or rarely accessed data. If your data is not updating or rarely you are accessing the data, at that time there is no need to cache that particular data. like administrative data or setting pages that are rarely visited. Once we set the values for the settings, we rarely visit that particular page. So that kind of a data is not needed to be stored. Now, there are again multiple scenarios, data integrity requirements, like banking applications where account balances and transaction histories must be up to date. So integrity of the data should be maintained. No use of a cache in that scenarios. Heavy write and read workloads are there, as I mentioned before also. If your data is updating or changing frequently, or heavy workloads are there, so how many times you will cache the data, right? It's continuously updating, it continuously write operations is of happening. If you have a complex data structures are there, complex NoSQL and kind of a different data structures are there, then don't go ahead with the caching. Because caching will be stored in the form of a key and value pair. Then how you will maintain that particular complex data under the things. Unpredictable access patterns. Now suddenly there are unpredictable access of the data is happening. Then in that scenarios, like applications with random access pattern, in that case not needed. Large data sets are there, then large files and all these things you can't store, memory issues will be raised. High availability and reliability required, don't go for the cache. Regulatory compliances, don't go ahead with the cache. So in summary, while caching can be significantly enhance the performance, it is important to evaluate the specific use cases and consider these factors to determine whether the caching is appropriate or inappropriate. Okay. So use of caching can lead to the outdated data, security vulnerabilities, and inefficient resources utilization. So there are advantages, disadvantages, what you want, go ahead with it. Now, next, in this particular video, we will try to cover one more concept, and that is nothing but enhance IO and data access. So all the do's and don'ts related to the data access, we are going to cover in a separate section, but little bit we just introduced the concept of how efficiently we have to handle the data access and enhance the IOs. So we are just planning to introduce that particular section here. Reading and writing the data consumes significant resources due to which the performance can be lowered. So therefore, you must make a following configurations to optimize and access the IO functionalities and to use only the required power. Now, there are some scenarios, there are some configurations they have mentioned. Okay, lower the network round trips and configure components to fetch all data in a one go. So basically, it is suggested that whatever you want, fire one query, fetch all the data, and come back. So in a instead of a multiple round trips to the database or to any data storage, just fire one thing, fetch the data, and collect the data in a one go. Prefer using node tracking queries for fast and accurate retrieval of a data. Go ahead with the node tracking queries. Implement logic to return only the requested data. So whatever the data you really want, only fetch the query for that data only rather than sending the whole things. If you want, consider there is 100% data, and if you want 80% of data, go ahead with all the data fetching. Now prevent using the projection queries and eliminate the n+1 SQL queries. Go ahead with the projection and configure and synchronous process executions for APIs sending and receiving the data, and follow async await for the API sending and receiving data. So in background, they will perform the work. So mostly when we check the performance of any applications, the time take most of the time will be waste, or most of the domains, or most of the technique which takes huge amount of time. Okay, and they includes this IO and data access. So we have to hugely take care of these things. So enhancing IO and data access is a crucial for optimizing performance in ASP.NET. Applications, especially for hot code paths, which are frequently accessed paths, So let's dive into some key strategies and techniques for improve I/O and data access efficiently. Now, efficient I/O and data access are critical for maintaining high performance applications, and especially in a hot code path. Here are some, okay, fine. Same thing get copy pasted. I'll reduce it. Now, first one is asynchronous I/O operations. So, asynchronous way we can perform the I/O operations to improve the responsiveness and scalability of that particular functionality. Enhanced database querying. Querying should be more specific, and efficient querying should be there when you are firing the query. Check whether the query is optimized way or not. Batch operation, rather than going firing multiple queries one by one, add those queries in a batch and fire that particular batch data. Perform a batch operation to reduce the multiple visits. Caching, implement the caching, efficient file IO rather than using normal read and write file classes. Go ahead with the streaming. Use appropriate data structures. This is also really means a lot. We have covered all the data structures in the first section. Choose proper data structure and that minimize IO operations also. Lazy loading and eager loading, take care of these things. Use the lazy loading for related entities, not always needed. Okay, and eager loading, which are frequently access data related data, then you can go ahead with the eager loading. Use NoSQL database for appropriate scenarios and consider NoSQL for high IO performance with the flexible schemas. So these are some techniques by following which we can perform or enhance the IO and data access of our application. Implement connection pooling. Use compiled queries, already compiled queries if you are using, so they will execute it fastly. And configure database connections to use the connection pooling. So you do not have to wait for the connection object. Now, each strategy is accompanied by the code examples and demonstrations, which we have mentioned here in a notes section, and they will explain how and why they are effective. Now, what are the key takeaways? Asynchronous programming is crucial for IO-bound application. Efficient database access, queries, compiled queries, batch operations, then there are some connection pooling. So all these things are useful for the enhancement of a database access. Choose right tool and data structures for your specific IO needs, and always consider the trade-offs between the memory usage and IO performance. The effectiveness of these strategies can be vary again, depending on your specific applications, need, and architecture. It is important to profile the measures that impact for the optimization in your specific context. Now, one more thing I want to mention that all these topics I am exploring. I am not giving you the 100% surety ki you are using all these things and then only your update product will be optimized or efficient or performance will get increased. Now, the situations may vary project to project, requirement to requirement. Now, you have to decide what you need to do. Now, common code parts, okay, fine. So here we completed our 2 topics for this video. I hope you will understand. And if you have any queries, we will try to resolve those in a next Q&A session. Thank you so much. Take care. Bye-bye.